Usually there are many different equivalent notations for entering the same Wolfram language program. For example, here is a short program that uses map and total to add up the first elements in a list of pairs of numbers. This program works by first evaluating the map part of the input to pick out the first element in each pair, and then total is applied to add up those elements. One alternate way of entering this program is shown by this input, where the map function is entered using the /@ operator, which is a special notation for the map function. This is the same program, just entered in a different notation. Another alternative, which is reasonable considering that total is applied at the end of the calculation, is to put total at the end of the input, which can be done using the // operator, which is the operator for entering postfix notation. Postfix is a technical term which means putting a function after the arguments of the function. Following an expression by /f, for example, is the same as applying f to that expression, so // total in the previous input is just another way of applying total at the end of the calculation. Another way of writing the program to add up the first elements in a list of pairs is to break the program up into two lines of input, with a first line that assigns the result from map as the value of a temporary variable, and a second line that applies the total function to that result. This way of writing the program emphasizes the two separate steps in the calculation. In that program, the semicolon is a special notation for a function called compound expression. The equal sign to assign a value to a variable is a special notation for a function called set, and the curly braces are a special notation for list. So without any special notations, that program could be written like this. This notation, based entirely on commas and square brackets, is called FullForm notation, which is the notation that is displayed by the FullForm function. For example, this shows the lists from that example displayed in FullForm notation. Most Wolfram language programs are written using some combination of FullForm notation and various operators and other special notations, such as in the form shown initially or in some other form. The choice of notation is in most cases a matter of personal preference, typically driven by choosing the notation that makes the program easiest to write or understand for whoever needs to write or understand the program. An important issue that comes up in inputs that include more than one operator is the question of which operator to apply first, or equivalently the question of which operator has higher precedence. For example, the input to apply the total function can be entered using square brackets around the list, or using postfix notation with the // operator, or using a prefix notation which is entered using the @ operator. The prefix notation for applying the total function gives yet another way of writing the earlier program, which again correctly adds up the first elements in a list of pairs. If the map function is entered using the /@ operator, however, then this program does not work as intended and instead gives a very different result. This happens because in that input, the @ prefix operator has higher precedence than the /@ operator, so total is grouped with first to get an expression with first as the argument of total, which is not a meaningful expression, and that expression is then mapped over the list to get the observed result. The underlying cause of the problem here is that the original input includes two operators, the /@ operator and the @ operator, and there is an ambiguity in deciding whether the function in the middle should be grouped with the /@ operator or with the @ operator. Two easy ways to resolve that ambiguity are to either use FullForm notation, which solves the problem by simply eliminating the need for one or both of the operators, or to use parentheses to specify how the grouping should be done. This input, for example, shows parentheses inserted so that first is grouped with the /@ operator rather than with the @ operator, which gives the intended result. Similar ambiguities can come up for almost any combinations of operators, including familiar operators like the plus and times operators in this input. In this input, parentheses can be inserted so that the addition is done first, which gives one result, or parentheses can be inserted so that the multiplication is done first, which gives a different result. If the parentheses are omitted, then the ambiguity is resolved by following the convention of doing multiplication before addition, or equivalently by following the specification within the system that the times operator has higher precedence than the plus operator. In the Wolfram documentation, there's a long list of operators in this page on operator input forms that shows, among other things, the relative precedence of Wolfram language operators. The Wolfram language has lots of operators, so this is a very long list. This list shows the multiplication operator higher on the list than the plus sign, reflecting the fact that multiplication has higher precedence than addition, and the @ sign operator is higher on the list than the /@ operator, reflecting the fact that the @ sign operator has higher precedence than the /@ operator. In practice, rather than memorizing or frequently referring back to a list like this, it's typically easier to just insert parentheses if the relative precedence of the operators isn't obvious or isn't known. Elsewhere in the documentation, there is a list of common special notations in this guide page on Wolfram language syntax, which includes basic FullForm syntax with commas and square brackets, the notation using curly braces for lists, the plus sign and other notations for arithmetic, and so on. There are other lists and tutorials that describe special notations that come up in selected areas of the language. This guide page on mathematical notation characters, for example, shows special characters that come up in mathematics. FullForm notation is frequently useful for understanding exactly what any particular notation represents. For example, expressions with a head of rule which are used for replacement rules can be entered like this in FullForm notation using commas and square brackets, but are more typically entered and displayed with a character that looks like a right-pointing arrow. The FullForm function can be applied to that result to see what is meant by that notation. The /. operator is a special notation for the replace all function, which is used for applying replacement rules. In an example like this, where the operator occurs in the input but not in the output, it can be useful to see the full form of the input before it is evaluated, which can be done by enclosing the input in hold before applying FullForm. For example, this shows FullForm applied to the input enclosed in hold, which displays the replace all function, which is the function represented by the /. operator, and the rule function, which is the function that is represented by the right-pointing arrow. In the notebook interface, information about some operators is also displayed by positioning the mouse over the operator. Positioning the mouse over the /. operator, for example, brings up a small window that includes a link to documentation for the replace all function. It's also possible to select the operator and choose Find Selected Function from the Help menu, which in this example also opens a page with a link to the documentation for replace all. FullForm is often useful for analyzing inputs that do not work as intended. For example, here are two similar looking inputs that apply a replacement rule. The first input does the replacement as intended, but the second input does not. The only immediate evidence of a difference between these inputs is a small bit of space between the X and the underscore character in the second input, which changes the pattern on the left side of the rule so that the rule does not match. This difference can be understood more precisely using FullForm. The underscore character is a special notation for a blank pattern, which is a pattern that matches any expression, and named patterns like x blank, in which the pattern is given a name, are represented using expressions with a head of pattern. The special notation for that is to put the name right next to the underscore without any space between the name and the underscore character. If the X is entered with a small space before the underscore character, then the input represents multiplication, since the space is a special notation for multiplication. Applying FullForm to the left side of the rule in the first input shows the expected structure for a named pattern, and applying FullForm to the left side of the rule in the second input shows multiplication rather than a named pattern, which explains why the pattern did not match and why the rule was not applied. FullForm can also be useful in situations where standard formatting does not show how an expression is represented. For example, FullForm shows that x minus y is represented not as subtraction, but as an expression with a head of plus, and in which one of the terms in the sum has a negative coefficient. Similarly, 1 over square root of x is represented not with a square root, but as a power of x with a negative rational exponent. The representation of subtraction helps to explain why the replacement rule in this example makes a replacement for x minus y, but not for x minus 2y. In that example, the pattern on the left side of the rule is the sum of x and minus 1 times a pattern, which matches x plus minus 1 times y, but does not match x plus minus 2 times y. Similarly, the rule in this example makes a replacement for the square root in the numerator, but not for the square root in the denominator, which happens because the square root of y in the rule is the plus 1/2 power of y, but the square root in the denominator is the minus 1/2 power of y. In practical examples, there are usually easy solutions to problems like these. One solution in these examples is to change the patterns to reflect how expressions are represented rather than how they are displayed. These inputs, for example, show one way to write rules that make all of the desired replacements. The rule in the first input replaces the sum of x and anything with a negative coefficient, which will make a replacement for anything subtracted from x. And the rule in the second input replaces any rational power of y, where the denominator of the power is 2, which will replace any power of a square root. FullForm can also be useful in analyzing some relatively uncommon problems involving similar-looking special characters. For example, the arrow that appears automatically when a replacement rule is entered is a special character called a rule character, but there is a similar-looking character called right arrow, which could potentially be entered by accident, which can be entered by typing backslash followed by open square bracket followed by the name of the character followed by a closing square bracket. Applying a rule with the rule character works as expected, but an almost identical looking input with the right arrow character generates an error. Since the rule and right arrow characters are entered in very different ways, it would be unusual to get the right arrow character by accident, but if that somehow happens anyway, the problem can be diagnosed by applying FullForm to the result, which shows a function called right arrow in the second argument of replace all rather than a replacement rule with a head of rule. It's also possible to select the character and choose Find Selected Function from the Help menu, which in this example brings up information on right arrow rather than the information on rule. The FullForm function and sometimes input form can be useful for understanding any formatted output, not just the notations that come up in programming. For example, here's a result from integrate that is displayed in a specially formatted way. In the notebook interface, positioning the mouse over that display shows that this is a conditional expression, or the structure of that expression can be seen using FullForm or using input form. In the Wolfram documentation, in addition to the references mentioned earlier, this tech note on textual input and output contains information on special notations and formats and on the broader topic of handling of input and output.